All right, so we're getting started, and as I said, I'm going to be just balancing out, okay, and doing different things together with you, giving you a lot of questions. I have to give you as many questions as I can. I have a math clinic tomorrow. I'm going to be doing questions from the time people wake up, and it'll be just maths, okay? I don't want to think about any other subject tomorrow. We just have to do a bit more of maths. So I'll be going through 2022 to 2026 doing algebra questions. So I'll share the link. Those who are awake early in the morning will be doing it with me. I think I'll start it early in the morning around 6 or half 6. And I'll be making videos that I'll put on the site. So answering question. And how I record it for the site is the same way I used to do it for engineering. So I record question by question. So on the site, you'll be seeing them as individual videos. On YouTube, it's one big video. So you join me, those who can, those who can't, we will. Now, today, what we're doing is we're looking at these two questions that have to do with trigonometry. And listen, I was marking Form 2 checkpoint maths, and they were doing angles in a polygon. So checkpoint is basically a very, very diluted version of IGCSE. Easy one. They don't give them hard questions. So it's like they just do a little bit of what you guys would do. They just say one thing, and they do many, many questions on that one thing. And they don't do the hard versions. I'll show you the version of IGCSE versus a checkpoint one. But what was making me very happy is all the work I marked, they all were following the same sequence, and they were getting 100% because of that. And I was very happy. I want to see it in your work, guys. Laura, Lefika, LGK, everybody, master the steps with me, apply them, and move on. You go to the next stage of your careers. Don't waste time. We have no time to waste. So I don't want to see anything I did not say. May I never be made to see workings that I did not say. I have said it in black and white. I don't want to see it. I'm going to tell you what to do here and the reasons. When you solve it, please just do as I say and move on. So listen closely. Everybody, listen to this. Okay, I'm going to be asking you questions as we move up, so that I don't talk too much. Okay, and you guys don't hear me. I want to make sure you're hearing me. So let me take a paper. This is very easy. Some of you already have seen it. Some of you may be able to do one particular one. But what I'm doing with you is the method that we'll use forever and ever, from now and forever. Okay? So that is what I want to train you guys. The method. Listen. I want to teach you what we call 3D tricks. So, trigonometry, IGCSE wants us. We are doing. Remember that IGCSE maths has 4 sections. Okay, maybe let me just show people. IGCSE maths. We are doing section 3. It has 4 sections. Okay, for us to say we are done with maths. I keep saying it every day. It's very important. IGCSE maths, 4 sections. Okay, for the whole thing. Number is the first one, where you deal with not probability, where you do with ratios, percentages, interest, bounds, time. Okay, when they tell you about time, or when you convert from one currency to another, what those things. Then you go to algebra. Has a lot of things. Similarity and congruence, variation, where you do inverse variation, direct variation, you do differentiation, you do simultaneous equations, all these things. Then here, unit 3, you do shape and space. It's called shape and space. That is where we are. Right. Listen closely. Listen to how you do this. I give you the questions, just do exactly as I've done. We move on. No wasting each other's time. There's a topic in Unit 3 called trigonometry. And people have done it many, many times in your schools in different versions. What we are doing is summarizing this together, okay? For mastering it one way for the exam. Listen, everybody. It's in section 3, okay? Section 3, this is where we have trig. Section 3 has trig, and it has circle theorems. They are part of a topic called geometry, okay? Geometry, you do circle theorems, and you do geometry of parallel lines. For those who watch Form 3 lessons, I'm sure you've seen me do this week. Parallel lines with them. And we were solving serious questions there. Anyway, and you do mensuration, which is the next thing I'm going to look at. Mensuration, okay? Volumes and surface areas, we'll be doing very hard questions there. Now listen, we are starting with trigonometry. I want to do a specific type of question. Trigonometry, for me to say you are done, you should just know this. You should know Pythagoras theorem. Okay, I'm going to try and give you and say these things easy. I don't want to over explain. So for me to say you are done, you must know the Pythagoras theorem, not your version. Okay, let me say it this way. My version. Okay, Pythagoras theorem, what I tell you. The right angle triangle and how you use the Pythagoras theorem there. Then, SOHCAHTOA, you should know what it says and where to use it. Pythagoras theorem, you should know what it says. It actually says something. And you must know what it says and how to use it. SOHCAHTOA, what it says, how to use it, where to use it. Then you must know sine rule. Okay? You must know sine rule. I'm giving you things that I'll show you. You should know what it says. And you should know where to find it in the exam, because it will be given to you at the beginning of the paper. And you should know how to use it. The way they will give you, how to use it, everything. Then you must know the cosine rule. What it says, you must know. How to use it, you must know also. And you must know where to use it. Where do you use the cosine rule? This is non-negotiables. You are not picking and choosing here. You don't choose to say, nah, I want to know this. This one I don't want to know it right now. This one I'll know it later. I don't want to know it right now. What? No, you can't. Then there's the last thing, which is area being half AB sine C. That's the very last thing. How to get area using this. There mustn't be anything on this page that you don't know. There mustn't be anything on this page that you as a person would not know. So look at this, everybody. Khami, switch off your camera. You switched on your camera by mistake. No problem. So now look at this. In the exam, they're going to give you this thing. It comes, I'll show you paper after paper after paper after paper after paper after paper, where they'll give you this. If Cambridge ever does this, this is 100% question. Everybody in this class, you are getting 100% here. Listen to what you do, okay? Listen to what you do. There is this thing which we have, which is called Pythagoras theorem. Okay? Pythagoras theorem can come as a question that I've just shown you, and we call it 3D Pythagoras. Okay? It's called 3D Pythagoras. So let me do that. This is the first question I'm going to solve with you. I don't want to over-explain because I'll end up hurting myself. By hurting myself, I mean you will not understand because I've over-explained. So let me keep it simple. I'm going to keep it simple. I'll explain other things after everyone is doing what I've said. May you do me a favor, ladies and gentlemen, boys and girls. Do me this favor. Listen. When you are going to do the Pythagoras theorem, just do for me the steps I'm about to do right now. Do for me those steps, finish it, leave it. Pythagoras theorem says this. It says you have a triangle, okay? I'm going to give it to you. Then we write how you're going to do it. You're going to do it in 2 steps in that box. It's called a 3D Pythagoras theorem question. So I'll give you question after question of 3D Pythagoras theorem. 3D Pythagoras theorem just means you are going to use Pythagoras theorem 2 times and you will have your answer. Simple. 2 times, finish, move on. Pythagoras theorem is the first part, right, of your trig. You mastering trig is mastering Pythagoras theorem. Listen to what Pythagoras theorem says. Sometimes it's called the Pythagorean theorem. It says when you have a right-angled triangle and you are dealing with sides, okay? You are dealing with sides. I can give them any letter I want. K, A, D. I'm just giving any letters I want. You have 3 sides. When you have 3 sides, okay, let's give them as numbers. 3, 4, then we can call this X. Huh? Or 3, let's start with letters, man. A. What did I put before? K-A-D. Pythagoras theorem says this. Do 3 things when you are writing this. It's a formula. Pythagoras theorem is a formula. So I want all of you to learn how to look at a triangle and make the Pythagoras theorem. When you are making it, do these 3 things. Okay? Pythagoras theorem. Okay? 1. Square every side. Square every side. When you write the Pythagoras theorem, listen, I'm just going to give you the rules, apply them, solve the questions, move on. Square every side, students. Then number 2, add the sides. Add the sides. Then number 3, hypotenuse must be alone. Hypotenuse must be alone. This is the exam version that I'm giving you. It's what we are going with in the exam and writing and moving on. Don't let me down. Listen, when you are writing the Pythagoras theorem, do these 3 things. You get a weird triangle, whatever. It should have a right angle. Then construct the Pythagoras theorem this way, not your way. I don't want it. Write this. You must square everything. Everything should be squared, squared, squared. That's rule number 1. Rule number 2, hypotenuse must be alone. Rule number 3, add all sides. Then we are going to apply to that box and we move on. So let's have this. I'm just giving you a simple situation. Then we'll do different versions. They will mix up the triangles, they're going to do a lot of things to try and confuse you. In the question which is coming in the exam will be hard. Although paper 2 can give you a simple version, but just you should know this one. So what you do, let's write Pythagoras here. Okay, for the triangle we have here, let's construct Pythagoras theorem. Then we will now start solving. First, let's construct Pythagoras. Right? First, you must choose for me which side is the hypotenuse for your triangle. To choose which side is the hypotenuse, go opposite the corner of the triangle. So I look for the triangle, I go opposite, I say, oh, this one is the hypotenuse for this question. Okay. This one is the hypotenuse. Why is he the hypotenuse? He is opposite the right angle. Not because I decide, but because he is opposite the right angle. So always write for me which side is hypotenuse first. Then now start the Pythagoras theorem. Remember, hypotenuse must be alone. So we start with the hypotenuse. In this case, it's D. So you write d squared is equal to, because hypotenuse must be alone, it is equal to the other two. What must they do? They must be adding. But what must they be? They must be O squared. So you say A squared plus K squared. This is a true Pythagoras theorem. Why is this true? Number one, hypotenuse is alone. D is alone. Number two, everything is squared. If you ever write anything and something is not squared, I don't know what maths you are doing. I do not recognize it. The third thing is that the sides are adding. So you are correct, Mr. Man. Then after this, you can now solve. First, oh, hi. Oh, okay. Oh, I'm sorry. Let me check. I'm sorry for that one. Wait, let me send it the link. Okay. Okay, let me add it and send it the link. Sorry for that. Let me quickly add it and put it. Is she online right now? Tell her to join the maths lesson. I'm sending the link to her. Tell her to join the maths lesson. Sarah. Okay. Hmm. Give me a second. There's somebody who's trying to join and there's a problem. Right. So this is the correct version. Listen, students. Don't ever change. Don't let me down, please. Write the true Pythagoras theorem. Then you can start solving. Steps must be followed. Math has rules. Imagine you're an engineer, you're building a bridge, then you don't follow the rules of trusses. Then you have an engineering disaster and you'll be arrested and put in prison. So this is going to just get worse. If you're a doctor, you have to follow a process when you're giving somebody medication. It's the same here. It starts in exams. Write for me the Pythagoras theorem, then you should solve. So we are going to go to this box they've given us. They've given us a box, students. They've given us a box. They will give you a box. Then they'll ask whatever stuff here. Find gx, whatever. Gx is this outside. Obviously, that's not what we find. We know what this is. This is 3D Pythagoras. This is 3D Pythagoras. So they'll tell you the length of the whole rod. Look, they told you that the whole rod is 40 centimeters long. So then they want the outside. Obviously, they know you should be able, the question is asking, it's checking if you know how to find this one in purple. Don't worry about GX. If you find the one in purple, you will remove it from 40, then you have GX. What you can find is the purple one because it's a diagonal. And how do you find it? You use Pythagoras. But when you are using Pythagoras, you have to respect Pythagoras. You have to write the true Pythagoras. Then solve. And then you write the true Pythagoras again for the second triangle I'm going to show you. Then solve. So I showed you the true Pythagoras. So we write him. Let's put him here. How do you solve this, Mr. Clarify? How do you solve this triangle? The first step is always this. You find the diagonal on the floor. Okay? When they give you this box and it has a slanted line, please find the diagonal on the floor first. It is part of this one. Look at it. It's this triangle, students. This one in green. It is this triangle. That's the one we first use. And this is your right angle here. Okay? Your right angle is this one. So first solve for the triangle on the floor. They will not give you that line. Make it. I'm now giving you the steps. You're not letting me down. No, no, no. Come on, don't let me down. That green triangle, put the diagonal on the floor and find it. That AC of theirs. This side, it's called AC. Find it. How do you find it? Using Pythagoras theorem. What does the Pythagoras theorem say? You have to write what it says. Respect it. It says, number one, everything must be squared. Is that true, class? Yes or no? Does Pythagoras theorem say everything must be squared? Yes, it says that. Square everything. Don't choose. Square everything. Then the second thing it says, hypotenuse must be alone. Then the third thing it says, add the other two sides when you're writing them. So first of all, choose for this triangle on the ground. Choose who your hypotenuse is. Who is the hypotenuse here? You go opposite the corner of your right angle to choose the hypotenuse. And you say hypo. Don't be the smart one to try and jump the steps. I still write these steps at my age. Why not you? Come on now. That's why I can get it all correct. Because I follow steps for every single question. So you write hypo. Okay? You write hypotenuse. Then now you know he must be alone. So you're going to say AC squared. We cannot write it without the squared. It will cost us. We'll be writing wrong things. AC squared. Now it is equal to the other two sides, 20 and 18. But they must be also squared. 20 squared plus, they must be adding. In Pythagoras, they add. Plus 18 squared. Okay, first you write Pythagoras. You know, the question is going to be different. Questions are going to be different. Solving them is going to be different. But there is one thing which never changes. It's the Pythagoras theorem. First you must write things like this. Then you look for what they are. Sometimes the thing you're looking for could be this one. But in this case, it's here. It differs. But first you write Pythagoras. Then you start solving. So now let's start solving. This one is easier to solve, okay? Because we are looking for AC. All we have to do to find AC, we now take this power of 2. We are done with Pythagoras. By the way, this is the Pythagoras theorem. This is the Pythagoras theorem. It's one sentence. It's not the whole thing. You should now know that what we are doing from here now is solving. It's not the Pythagoras theorem is just this one sentence. And I want to see it correct for every right angle with every triangle with a right angle that you solve. I want to see a correct version, not a false version. Now you find your AC. We are now solving, okay? We are done with the Pythagoras theorem. Make no mistake about that. We are done with the Pythagoras. Now we are solving. We take squared to the other side. It becomes square root. So here we remain with AC because we want AC. So we have to remove this one now. It goes to the other side. It becomes a big square root. This power of 2 goes to the other side. It becomes a big square root of what? Of the things that were there. 20 squared plus 18 squared. Then now we can find what is AC. What is AC? Tell me, class. Punch now. You can punch. Everybody practice punching. square root open bracket 20 squared plus 18 squared close bracket is equal to, what do you get? Come on, students, you can punch this now. What is the answer? Say it. I can't really hear you. Oh, something is wrong with the mic, Antonisha. I can't hear you. What did you say? (26.91 centimeters). This is now 26.91. This is this one. Good. Don't round it off too much, okay? Try to keep it with as many significant figures as possible. Then now we go to the second one. Okay? You remove the word AC, you write 26.91 centimeters. Now we have done the first Pythagoras. Now, Mr. Warrior, you need to do the second one. So this is how you now solve it. You should get used to it, class. 2 steps. You should get used to this one. 3D Pythagoras. 2 steps. I said first you do it so that you find this one. Now that you have this one, you now do this one, this triangle, which I'm putting for you in red. This triangle in red is also a right angle triangle because the right angle is here. Can you see that? That's the second one which you now do in red. Can you see it? Can you see it now? Good. This side is 26.91. This other one they gave you here thinking you don't know. If this is 16, obviously you come here and write this is also 16. Okay? This is also 16. So now we know 26.91, 16. What about this one? We don't know it. It's called AG. Okay? You do it like this. Now it's time to start solving. Okay? We are going to apply Pythagoras theorem the second time. And don't change it. How do you apply Pythagoras theorem? How do you this is all that matters. You writing the truth. How do you write Pythagoras theorem? You have to know who is hypotenuse first. So you go opposite the corner of your right angle. You see that AG is the hypotenuse in this case. Oh, okay. The hypotenuse is AG. Okay. So now I can write the Pythagoras theorem. What do you know about it? It says everything must be squared. Hypotenuse must be alone. And the other 2 sides must be adding. So who is hypotenuse? AG. He must be alone. But he must be squared. Everything has to be squared. So you now write AG squared is equal to, now you put the other 2 sides. What are the other 2 sides? 26.91 and 16. 26.91 squared plus 16 squared. They must be adding. They must be squared. You know, if you write this, I will clap hands for you. I'm so happy. I want to see this. Okay, remember to skip a line here. You are now doing Pythagoras theorem number 2. Okay, to now continue to find the one that they actually want. So Pythagoras theorem the second time. So that's the only difference between this one and other. When they give you as a box, remember this. You will apply Pythagoras theorem 2 times. Finito. What is hard about that? You don't want to do it? Huh? You don't want to apply Pythagoras theorem 2 times? Surely you can do that. Come on now. Now let's find the AG. We take the squared to the other side. Okay, we now need to find AG. We take squared to the other. I don't want to see anything I didn't do. I don't want to see anything I didn't do. I don't want to see it. Please. AG goes to this power of 2 goes to the other side. We said it becomes a big square root. That's what we said. Of everything that was already there. That's what we said. What is it? What is the answer? What is your answer for AG? What will you get? What is the answer you get, students? What is the answer now for AG? Something is wrong. I can't hear. The volume is low for Antonisha. What did she say? Tell me what she said. 31.31 centimeters. So now you have it. 31.31 centimeters. Okay, centimeters, because everything was in centimeters here. Then you're done. You can get your marks. In this case, they just wanted you to find GX. So you now say GX, which is the outside part. You know that this AG is the one which is 31.31 centimeters. So now they want you to find GX, which is this piece which is outside. Okay, that's not a problem. You just say GX is equal to, the total rod is 40 centimeters long. So you just say 40 centimeters minus 31.31 centimeters. You know, GX is going to be 8.69 centimeters, which you can round off to be 8.7 centimeters or whatever. The most amazing thing about this is not the answer. Make no mistake here. What will amaze me the most about this, if you submit an answer like this, is not the answer. It's the stages. I will see and know that you are 100% student because you follow steps. You are very obedient to the steps. I don't want to give you too many things. Okay? So I'm going to give you questions on this 3D Pythagoras. Okay? As many as I can find. As many as I can give you. Please follow the steps, please. Okay? I'm going to do different versions of Pythagoras in our lesson, in our next lesson, okay? To just show you how they'll try to trick you. But where we will stay, what will make us always get things correct is we will not write a wrong Pythagoras, okay? To try and get the answer by changing things. No, no, no. There's one thing I'm not going to allow. If you write a wrong Pythagoras, I don't want to see that. Please write the correct Pythagoras. Hypotenuse should be alone. Everything must have a squared on it. And the other two sides should be adding. Not subtracting, adding. Please. That's the correct Pythagoras. Then we can start to solve from there. So here we did it 2 times to find the bottom. We first found that bottom diagonal using Pythagoras theorem. Then we used it to find the bigger diagonal using Pythagoras. This is the trick. We'll use it over and over and over and over and over and over again. Get me 100%. Come on now. Just do this correctly. Get me 100% and make me happy. Students, have we agreed? Are we in agreement? Class, are we in agreement? Just do these steps and move on. Don't waste my time. Don't waste your time. You don't have time. Just do this and move on. Okay, I'm going to give you questions. And you have to do them, submit them, and tomorrow we move on. Simon, did you see this? I'm counting on you, Simon. I'm counting on you guys. Everybody, Lehakwa, I'm counting on you guys. Please, please, please. I'll send you the questions into the group. Do me the correct thing. Submit. Move on. Okay. Maths is done. Goodbye. That's it for maths.